Hello friends, welcome to Learner's Planet. Friends, in this session, we are going to take some more problems from CAT 2002 papers. In the previous session as well, I have taken good number of problems on from CAT 2002. In this session, we'll be taking more problems from the same paper. Okay, so let's begin the session. Now friends, let's take this question. On a 20-kilometer tunnel connecting two cities A and B, there are three gutters, 1, 2 and 3. The distance between gutters 1 and 2 is half the distance between gutter 2 and 3. I just draw the diagram over here. It's city A and this is city B. This is gutter 1, 2 and 3, right? The distance between gutter 1 and 2 is half the distance between gutter and 2 and 3. So suppose this is 2x, it will be x, right? The distance from city A to its nearest gutter, gutter 1, is equal to distance of city B from gutter 3. Suppose this is D, then this is also D, right? On a particular day, the hospital in city A receives information that an accident has happened at gutter 3, right? So this is accident site. The victim can be saved only if an operation is started within 40 minutes. An ambulance started from city A at 30 and crossed gutter 1 after 5 minutes. If the driver had double the speed, that what is the maximum amount of time would the doctor get to attend the patient at the hospital? Okay, so what a big story. Let's do it. First of all, an ambulance started from city A at 30 km per hour, right? So from this place, the ambulance is starting at 30 km per hour, and to reach this at gutter 1, it's taking 5 minutes, right? So what is the distance that it has covered? That is 30 into 5 by 60. This is in minutes, so I just convert it into hour. So it's 5 by 2 kilometer. That's 2.5 kilometer, right? So this is 2.5 kilometer. So this is also 2.5 kilometer, and the total length of that AB is 20. So this is 2.5. This is 2.5. So that's 5 has gone. Now that means this complete length is 15. So this is 5. This is 10, right? And this is the accident spot. That is 2.5 plus 5 plus 10, that is this much away from the city A, hospital at city A. Now after this point, the driver is doubling the speed. That means as of now the speed is 30. Now it's making it to 60, and he has to cover up the distance as 15 kilometer. So 15 kilometer with the speed 60, he would take 1/4 of an hour, that is 15 minutes, right? So I just write the timings over here. Initially from A to this is 5 minutes, then from this place to this place 15 minutes, then 1 minute is elapsed into and out, so I just add 2 over here. Now this 2 is separate, but 5 plus 15 is that time that is from A to gutter 3. Now while coming back, the ambulance has to cover up 10 plus 5, 15 plus 2.5, 17.5 with the speed of 60. So the timing will be 17.5 kilometers with the speed of 60. So this is the time in hours, multiply it by 60. So this is the time in minutes. So 17.5 minutes to reach this place, right? So this is the total time from beginning to end. So this is 15 plus 5, 20 plus 2, 22, 22 plus 17.5. It's 39.5, right? I'm sorry, this is actually 1 minute. 1 minute is taking and into and out to is 1 minute. So it's precisely the whole time is 21.17.5. That's 38.5, right? So 40 minutes and 38.5 minutes. So 1.5 minute is the time which doctor get to attend the patient, right? So in all, it's a big story, but the problem is not difficult. It's simple problem based on time, speed, and distance, right? I hope you are clear. Now friends, let's try this problem. A child was asked to add first few natural numbers so long his patience permitted. As he stopped, he gave the sum as 575. When the teacher declared the result wrong, the child discovered that he had missed one number in the sequence during addition. The number he missed was. Now, what is the sum of first n natural numbers? That is n plus 1 by 2, right? And the child is adding first n natural numbers. Do not know the value of n, but it should be definitely, the sum should be definitely bit greater than 575 because he has missed one number, right? So this should be greater than 575. Now we have to find out the value of that one missing number, right? Now what we have to do is, by trial and error, we have to calculate the value of n, or we have to find out the value of n. So this expression is greater than but closer to 575, right? So just by hit and trial, what we can do is n plus 1 should be greater than 2 into 575, that's 1150. So n plus 1, 30, 31, 31, 32. So probably 32, 33. No, 34, 35. 35 twos are 70, fours are. So it's 1190. Yeah. So n can be 34. So n plus 1 will be 35. Okay. That means he is trying to find out the sum of first 34 natural numbers. Now what is the sum of first 34 natural numbers? That is 1190. I'm sorry, this is 1190 by 2. I just put it over here. It's 34 into 35 by 2. That is the sum of first 34 natural numbers. So that's 595. So he is getting the sum as 575, but the sum of first 34 natural number is 595. That means he has missed one number, that is 20, right? He has forgotten to add 20. That is the difference of 595 and 575. So according to the options, it's more than 15. Okay, I hope you are clear. Now let's see this problem. 10 straight lines, no 2 of which are parallel and no 3 of which pass through any common point are drawn on a plane. The total number of regions infinite and infinite into which the planes would be divided by the lines. Now friends, there's no specific formula for this particular condition. So what we do, by hit and trial, we just try to get a formula or a relationship which we will be using to find out for the train 10 lines, right? So we start doing finding out the relationship from 1 and 2 or 3 lines. Okay, so if I have just one line, I'll be getting 2 regions, right? If I have 2 lines, so I'll be getting 1, 2, 3 and 4 regions. If I have 3 lines, similarly, it's 1, 2 and 3. So how many regions I would have? Here I'm having 2 regions, here 4, and here 1, 2, 3, 4, 5, 6 and 7 regions. Now suppose if I draw 4 lines, so if I have 4 lines, the figure will be something like this. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11 regions will be there, right? So for 1 there are 2 regions. If there are 2 lines, there are 4 regions. If there are 3 lines, then there are 7 regions. If there are 4 lines, there are 11 regions. Now we got the steps. We can derive a relationship or a formula for the same if the number of lines increases. Okay, Now here the difference is 2, here the difference is 3, here the difference is 4. So I just write it 5, 6, 7, 8, 9, 10. So here the difference is 4. Now after that the difference will be 5. So 11 plus 5, 16. Then the difference will be 6. So it's 22. Then the difference will be 7. So it's 29. Then the difference will be 8. So 29 plus 8, 37. Then the difference will be 9. So it's 40. 6, then the difference will be 10, so it's 56, right? So if there are 10 straight lines, 56 regions will be formed. Okay, I hope you are clear. Now friends, further we have a long story, problem based on time, speed and distance. A train approaches a tunnel AB. Inside the tunnel is a cat located at a point that is 3 by 8 of the distance AB measured from entrance A. When the train whistles, the cat runs. If the cat moves to the entrance of the tunnel, the train catches the cat exactly at the entrance. If the cat moves to the exit B, the train catches the cat at exactly the exit. Now we have to find out the ratio of speed of train and cat. Now suppose this is the tunnel A and B, and this is the point where the cat is there. So I just assume this point to be C, right? And this is like 3 by 8. This point is dividing this complete tunnel into 3:5 ratio, right? So this is like 3, this point is 3 by 8 of the total distance or total length of the tunnel, right? So this is 3, this is 5. Okay. Now suppose train is whistling from here, right? Now when the train reaches over here, the cat also reaches over here. Now I assume this length to be x, right? So in the time the train covers the distance x, the cat covers the distance 3. This is 3 kilometer or maybe 3 meter, whatever. So 3 unit. So in the time the train covers the distance x, the cat covers the distance 3, right? That means speed. So ratio of speeds of train and cat will be speed of train by speed of cat will be x by 3, right? Because time is constant, so speed is equal to distance by time. If time is constant, the speed ratio will be with respect to distance only, right? So speed of train by speed of cat will be in the ratio of x by 3, right? Now the other incident by which we can calculate the ratio of speed of train and cat is when cat covers this 5 units. Suppose cat is here, that we assumed in initially. So if cat covers 5 unit, in the same time the train covers x plus 8 unit, right? Because they are meeting exactly at the exit, right? So in that case, the ratio of speed of train will be and cat will be x plus 8. That means this length plus this complete length, since they are meeting at exit point. So x plus 8 by 5, because cat is starting from here and train is starting from here, right? Now this is the ratio of speed of train and cat. Both of them are same, so we can get the value of x. So it's 5x is equal to 3x plus 24. So x is equal to 12, right? Now what is the ratio of speeds of train and cat? That is 12 by 3, or we can say 4 by 1, or 4:1, right? So a long story but a very simple solution. I hope you are clear. Now this question: in how many ways is it possible to choose a white square and a black square on a chessboard so that the squares must not lie in the same row or column? Quite an interesting problem. Um, Friends, there are 32 black squares and 32 white squares on a chessboard, right? I just draw a small chessboard over here. That's something like this. I'm not drawing 8 by 8. I'm just making a small one. Right? Now the alternate is black. Okay. So we have to choose one white and one black, but they should not lie in the same row or column, right? So first of all, what we do, we choose a white square. So out of 32, we have to choose one white square, right? So we have how many ways? It's 32, C1, or we can say 32, right? Now we have to choose the black one, but that should not lie in the same row as the white one or the same column as the white one, right? Now suppose we are choosing this white one, particularly suppose this white one. So it should not be in this line and in this line, okay? So in this line, there are in all 4 black, and these 4 black we have to we don't have to take into consideration, and similarly in this line there are 4 blacks that we don't have to consider. So in all, we don't have to consider the 8 blacks which are lying in the same row or column as this white square, right? So in all, there are 32 black squares, and out of 32, 8 we cannot consider or we cannot choose. So remaining are 32 minus 8, that's 24, right? So in all, there are 24 ways to select a black square when this black is not lying as the same row or column as the white square, right? So it is 32 into 24, that's 768. Okay, a very simple problem based on permutation combination. I hope you are clear. Now 7 raised to 6n minus 6 raised to 6n when n is an integer greater than 0 is divisible by. That means n is a positive integer. Now if you take the minimum value of n, that's 1, what we say is 7 raised to 6 minus 6 raised to 6. Now 7 and 6, both of them are having same n even power. So it's a6 minus b6 format. That means a cube minus b cube and a cube plus b cube will be their factors. That means it is divisible by both of them, right? Now a cube minus b cube is what? A minus b into a square plus ab plus b square, and a cube plus b cube is what? A plus b, a square minus ab plus b square. That means this expression is divisible by a minus b and a plus b both as well, right? So let's see what happens in this case. So it's a minus b will be what? 7 minus 6, that's 1. So okay, now a plus b will be what? 13. Yeah, it's divisible by 13. Now this expression is divisible by a square plus ab plus b square, so that also we have to see. Or I can say this expression is divisible by 7 cube minus 3 cube and 7 cube plus 3 cube both as well. Now what is 7 cube? That's 343. What is 6 cube? That's 216, right? So it will be divisible by 343 plus 216, that's 559. So it's divisible by 559 also. And 7 cube minus 6 cube, so that's 127. So it is divisible by 127 also, right? So this expression is divisible by all of them. Okay, so the problem is going to be simple, just simple factorization we are making over here. I hope you are clear. Now friends, let's see this question. If PQR is equal to 1, the value of expression this is equal to. So in this sort of question, just assume the value of the variables, right? We want the product of P, Q and R as 1. So what we do is we take the value of P, Q and R, all of them as 1, right? Now if we put the value of P, Q, R and P, Q and R as 1, we'll be getting 1 by 3 plus 1 by 3 plus 1 by 3. That means the overall solution to this problem is 1, right? So if you wish to cross verify, you can take the other values of P, Q, R. Say P is 1, Q is 2 and R is half, right? So now let's put the value of PQR in this expression. So it's 1 upon 1 plus P plus Q raised to minus 1. So it's 1 plus Q raised to minus 1, that's 2 raised to minus 1. So it's half, then plus 1 upon 1 plus Q plus R raised to minus 1, that will be 2, then plus 1 upon 1 plus R, that's half, plus P raised to minus 1, that's 1 only, right? So it's 1 upon 2.5, that's 5 by 2, plus 1 upon 5, then plus 1 upon 2.5, that's 5 by 2, right? So it's 2, 3, 4, 5. So still we are getting 1. That means our solution or the answer is independent of variables, right? So this is 1. I hope you are clear. Now let's see this problem. It takes 6 technicians a total of 10 hours to build a new server from direct computer with each working at the same rate. If 6 technicians start to build the server at 11 a.m. and 1 technician per hour is added beginning at 5 p.m., at what time will the server be completed? Now friends, it's a simple problem based on time and work concept. We do not make the problem complicated, just calculate the man hours, how much time will it take to make the server complete, right? Now 6 technicians and total they are taking 10 hours, that means it is 60 man hour work, right? Now they are starting at 11 a.m., right? So from 11 to 5 p.m., that means for 6 hours 6 persons are working. So for 6 hours 6 persons, that means 36 man hour work is completed till 5 p.m., right? Now from 5 to 6 one more person is added, so 7 man hour work will be completed. This from 5 to 6. Then from 6 to 7 one more person is being added, so 8 persons will be there, so 8 man hour work will be done. Then from 7 to 8 9 persons will be working, right? Then after that more persons will be added, so let's see whether it makes 60 or not. So 36 plus 7, that's 43. 43 plus 8 is 51. 51 plus 9 is 60, right? So till here 8 o'clock was there and 60 man hour work is completed. So the entire work will be completed by 8 p.m. Okay, it's a very simple problem based on time and work. Just calculate man hours and proceed like this. I hope you are clear. Now friends, let's see a simple problem on time and work. 3 small pumps and a large pump are filling a tank. Each of the 3 small pumps work at 2/3 the rate of large pump. If all 4 pumps work at the same time, they should fill the tank in what fraction of time? Then it would have taken the large pump alone. Now we assume that the large pump is taking X hours to fill up the tank completely. Now the smaller pump's capacity is 2/3. That means it would take 3 by 2 X hours to fill the tank, right? Each of the smaller pump. Now if all of them are working together, that means in 1 hour the large pump will fill 1 upon X part of the tank, and the smaller pump will fill 2 by 3 X part of the tank, and there are 3 pumps like this. So in all 2 by 3x plus 2 by 3x plus 2 by 3x. So this is the situation. So in 1 hour 3 by x part of the tank will be completed. That means it would take x by 3 hours if all of them are working together. And for the larger pump it would take just x hours. So we can find out the ratio. That's x by 3 by x by 1. So it's 1 by 3, right? So that is the ratio. I hope you are clear. Friends, I hope you might have enjoyed the session. In the next session, we'll be taking the problems from CAT 2003. So do revise this session and the basic sessions as well. So I'll see you in the next session once again. Bye-bye.